Good morning, ladies and gentlemen, and welcome to Malaga for this opening session of the 35th edition of EuCNC and the 8th edition of the 6G Summit. It's a real pleasure to welcome you to Malaga, and it's a real especially meaningful to welcome you to Malaga, which hosted this conference for the first time back in 2019, and now once again it becomes the key meeting point for the global connectivity community. And today, I have to say that we are very delighted also to welcome participants from more than over different countries. That diversity is what makes this summit so unique. One shared space where ideas, perspectives, and innovation truly come together. Over these 2 days, we're going to explore how communication technologies are evolving from advanced 5G systems to the emerging vision of 6G and how they are shaping and will shape our societies, industries, and daily lives. I have to say that we are today joined by distinguished speakers, as you can see, 5 speakers. So without further ado, I will introduce them to you. They are representing academia, industry, public institutions, and European policy making. They will offer different perspectives on one shared ambition, shaping the future of connectivity, innovation, and digital transformation in Europe and beyond. So let's welcome, with a big and warm applause, our opening session speakers, starting from Professor Pedro Merino Gomez, General Chair of EuCNC and 6G Summit, Mr. Thibaut Kleiner, Director for Future Networks at the European Commission, and of course we have Ms. Erzsébet Fitori, Executive Director of the Smart Networks and Services Joint Undertaking, Professor Juan Teodomiro Lopez Navarrete, Rector of the University of Malaga, Mr. Francis Sala, Director of Pro Malaga in the Malaga City Council, and of course, Mr. Matías González, Secretary General for Telecommunications, Digital Infrastructure, and Digital Security of the Government of Spain. Looking around this room, it's inspiring to see how many people are working together to shape the future of communication technologies. Ladies and gentlemen, let's start this session, and it's my pleasure to invite someone who has been deeply involved in the EuCNC community and in shaping its academic and research excellence over the years. Please, let's welcome with a big and warm applause, Professor Pedro Merino González. Welcome.
Thank you, Romina, for the introduction. Thanks a lot, everybody. Welcome to Malaga. Morning, colleagues. It's my pleasure to open this session after so many years of working hard with a large team at the university in collaboration with Telefónica. I'm really happy to have here Thibaut, Kleiner, Erzsébet, Matías, the General Secretary. Javier Lopez is replacement today for the Rector. He will explain later the reason. Francis Salas is representing the city. And I see also so many people from the European Commission and the SNS and the regulator from Spain, who is providing also the spectrum to us. So thanks, everybody. Also, my co-chairs, Ivan, will introduce later the keynotes. We miss Ari Puto, the vice chair, because of health reasons, but I'm really happy to see all the colleagues here. EuCNC is the European Conference on Network and Communications, joined with the 6G flagship, initiated in Oulu, in the 6G flagship. We are in the 35th edition of EuCNC, so it's a long-term European conference. Today, the main activity or the main motto of the session of the conference is 6G connecting intelligence. That means connecting services, connecting people, but it means also involving the network, managing the network inside the network and putting more artificial intelligence and machine learning into the network. This is the main topic you will see in all the sessions, in the keynotes, probably in the panels, everywhere. There are many other topics, but this is the main conductor or the main driver for the whole conference. Just to give you some statistics, we send the call for papers as usually, expecting some specific topics, a number of tracks, but at the end, what we have is what you have submitted and what the committee, the program committee has accepted. You see, we have 195 papers to be presented. We have no more space, so we had very, very good papers that were not selected because of space. We have a record of submissions, 423. This is the record in the last editions of EuCNC. Then we have a number of special sessions, means special topics proposed by the community or by the steering committee. Those are the convened sessions. We have 4 tutorials that were running yesterday with many people in the rooms. We have 16 workshops also running yesterday. Posters in the rooms today, 2 sessions. And then we have a very, very large number of booths with activities by companies and by projects. This number represents actually more than 126 square meter booths. They are combined in many cases. And we have, for instance, the French, let's say, area, the Taiwanese area, and we have a number of clusters where companies and institutions from those countries are showing their scientific and technological developments. We will have also some awards for theses, startups, and so on. There are 3 main topics if you go to the papers, to the special sessions, to the tutorials, panels, everywhere. Main topic is artificial intelligence and machine learning for communications, services, and the network. And this is what you will see mostly in the conference. Second topic is mainly in the workshops and special sessions, but also in the papers, is integrating sensing and communication. That means using the network just not only for communications, but to get information on the environment, to know what is happening in the environment and to make decisions because of the services or because the authorities, decision makers, can have this information, for instance, about traffic or just people in the area or any potential critical risk. And 5G over satellite. This is something that will be a 6G feature because we need to increase coverage, in particular when we have remote areas or when we have some events, some critical events and risk, and we need to provide connectivity to PPDR, I mean to forces that are in charge of emergencies, public protections, and so on. You will see demos and you will see scientific contributions in these 3 areas in the conference. Just for the colleagues who were submitting papers, these are the statistics. It's public also in the proceedings, but you can see that artificial intelligence machine learning is the winner in terms of submissions, also in terms of papers presented in the conference. Physical layer is the second one, and obviously will be also the second in the number of sessions devoted to this topic. And then in the others, distribution is more or less balanced to get these 195 papers accepted that will be in 39 sessions, in sometimes parallel sessions in the same track, where we can avoid, we have separation of the tracks. This number will be shared also later in the proceedings. The program, as you have seen, we are filling 4 days, 4 days and a half. Yesterday we had the workshops and the tutorials. Today, after this opening, we have 2 keynotes by Telefónica and Ericsson. Tomorrow we will have again 2 keynotes coming now from the scientific academia, from the colleagues. When you see oral sessions, we are running up to 12 parallel sessions with tracks for papers, with special sessions, and with convened sessions. There are a few novelties this year. First one, we are testing a 5G private network, actually 2 5G private networks, and we have a spectrum, thanks to the regulator. We have the license, we have the eSIMs. This is another point. You don't need to put the hardware eSIM. So in theory, you can connect to the 5G private network with the eSIM that is called Victoria Network and also to the Orange Network. And the reason is to have connectivity in the event for the demos. So all the booths can be connected to the network for the demos. And you can use the network for any kind of activity. And the main objective is to produce data sets. We want to have the EuCNC data sets. What are you doing in the conference? In order to give an input later to the projects. And then the other novelties are in the program. We have more papers than in previous editions. We have more time for exhibitors. we have this exhibition and drinks. It is not called in this way in the agenda, but after closing all the sessions in the afternoon, you will have 1 extra hour in the exhibition with some drink to show the demos. And we have some outdoor demos. Today you will see Fidal demo outdoor. ISA demo was outdoor, but due to the temperature yesterday, we need to put the van inside for a while. It's a bit small, but maybe you can see the distribution of participants per country. Not surprised, usually there are 4 big countries providing most of the participants. Not surprised, Spain this year, usually. We have a number of people from Spain, but of course this year we have more. So you see here Spain, Germany, France, Greece. The others means we have a number of volunteers, press, and many people that we don't put in any specific country. But we have 40 countries. I want to say 6G should be a global standard. So this is a European conference, but should be global. And we are working in that direction. For instance, Javi, the co-chair, Ivan Seska from US, and we are attracting many people from Taiwan, Japan, South Korea, United States, and many other countries. So we'll be the scientific and technical conference for 6G at global level. This is the ambition. We have more than 500 people working in the conference, apart from the, let's say, authors submitting the papers. We have a very large set of reviewers, the steering committee, the technical program committee, the organizing committee, and the patrons. Thanks a lot to the patrons, because this year they contribute a lot with the stands and also with the funding to the conference. You have here the logos of the patrons. The 2 main patrons are from Spain, Telefónica and Ericsson. Okay, Ericsson is Sweden and Spain, but the colleagues from Spain make a great effort here. Thanks a lot to all the patrons for their contributions. Let me also thank especially to the 2 colleagues, Javier Garcia and David Artuñedo, because the proposal to be here today was something we started in Gothenburg a few years ago. We made the proposal to the commission, to the steering committee. We were breaking some rules because usually the assignment of the site to the conference follow a different rule. But fortunately, we got the conference. We are really happy to be here with all of you. And this is about 6G, 5G. It's also about Malaga, so please take the opportunity to visit also the area. I know many of you were the previous weekend. You will be maybe the next weekend also. Enjoy the conference and enjoy the city. Thanks a lot for coming here.
Thank you so much, Mr. Pedro Merino. Thank you for summarizing, visualizing what waits for you and what we have prepared for you during the next hours. And now, from this perspective, we're going to move on and focus on the vision of the European policy, vision behind connectivity and digital transformation. Thibaut, Kleiner, it's your turn. Big warm applause to him, please. Welcome, we're all yours.
So good morning. Thanks a lot, Pedro, for the great introduction. Ladies and gentlemen, esteemed guests, it's really my pleasure to be here, to be back, I would say, in EuCNC and to the 6G Summit today. Last year, I could not be there, even though I'm the chair of the conference, but I didn't want to miss this year in any way, even though we have an important development today in Brussels. And that's what I wanted to start with, because today marks the adoption of an important package, the tech sovereignty package. And we call it, actually, today, we call it our Tech Liberation Day. It's the day we announce we announce a series of measures where, we try to basically change a bit the mood around Europe, to stop having this impression that we are not only here to regulate, we are here to make the future in Europe. We are here to develop technology, and I think this conference, and I think the size of the contributions is just a token for what is ahead of us. Today we are presenting a very ambitious package that will cover cloud, AI software, that will cover chips, that will cover open source as an opportunity. And all this, we believe, will be a turning point in terms of the focus, not only of our member states, but also of our industry, of our research communities, so that we look maybe differently at our opportunities. I think today we can start to be, again, more ambitious in terms of the future. We can start looking at our opportunity to build a full technology stack, not just being excellent in connectivity, but being excellent from the hardware to the software. And our tech sovereignty package is also a way to recognize our important strength. Sometimes we take it for granted, but we have really in Europe first-class talent, we have fantastic research labs, we have great open source communities, actually the largest globally, bigger than the United States. We have leading companies, in particular in the connectivity remit. And sometimes we tend to take it for granted that we have just to adopt the technology from abroad, but it's not true. We can just do it ourselves. It's just a matter of focus. It's just a matter of believing that we can use these ecosystems for the best. And this is really important today because with the acceleration of AI, with the acceleration of investment in data centers, now is really the time to shift the focus and to make it clear that it can happen here and it will happen here. In fact, if you look also at the technological development, there is a very exciting convergence between technologies. Networks, edge computing, cloud, and AI are merging to develop new solutions. This is a huge opportunity because it means we can reinvent a lot of our business models. We can take back some of the markets that are leaving our leadership. In a way, we can look at traditional telecom networks as not only essential facilities. I mean, imagine you don't have electricity suddenly. The world stops. This is what Spain experienced a few months ago. Imagine you don't have telecom connectivity. The world stops as well. And I think that's the essential element that we need to repeat time and again. There won't be a digital future unless we have great connectivity. But even more, these networks are becoming not just transmission of data, they are becoming the gateway for intelligence. And that's the new business model that we need to tackle. Telco as the place for intelligence, as a way to access AI, as a way to make resources available so that you can develop these extremely interesting services, from autonomous, self-optimizing networks with sub-millisecond latency, high energy efficiency, and proactive security. That's the network of the future. But the network of the future is also where you find the resources to power your drones, your connected cars, your robots, and your smart glasses. This is where you need to have also the intelligence, and this is how the intelligence will reach you. So we have an opportunity now to bring this tech sovereignty agenda together with our connectivity efforts. And this means investment. And that's today also the signal we want to pass. Europe is open for investment. Our tech sovereignty is not about excluding anyone. It's about attracting the best. It's about attracting investment. It's about making this location where people want to go. And we have interesting signals. Imagine today there are more people that come from the US to Europe than the reverse. So we are reversing the brain drain somehow. And I think we need to do more. We need to get the best people from all over the world joining our labs, joining our companies, and adding opportunities. Because the convergence of connectivity, cloud, and AI is a winning ticket that we are already embarking on. But I want also to add quantum to that list, because also there we see quantum connectivity as a very important element. It was not so prominent in the list of papers, but it's coming there as well. And I think also here we see leadership in Europe. We have some of the best researchers, several Nobel Prizes recently, It's not only about quantum computing, it's also about new applications from sensing to healthcare to secure connectivity indeed. So really, we have a lot of assets that we need to mobilize, and we have the opportunity to make Europe the best place to develop the future. And the Commission will play its part in this journey. We will indeed not only organize the regulatory space, and I think today is also an important way to say that we can use our regulation as an asset. In the United States, more than 60% of people are worried about AI. In Europe, it's much less, it's around 25%. Why is that? Because we have adopted a regulatory framework that very explicitly looks at the risks and organizes that the risks are mitigated. So we can use this to build trust in technology and to win the adoption of AI. That's really also what today's announcements are about. Adopt technology, make technology in Europe, and lead in the deployment. And in the future, we want to make more from our EU funding. I mean, today, as you know, there is a lot of investment from the European budget into research and innovation. We want to do more, but I'm really pleased where we are with SNS-JU, and I'm sure that Erzsébet will say more about this. We've already more than 100 projects running, more than 600 million public funding. The results are really here to show, and look around because there are many projects in the exhibition center. It's really high-quality research, results that go into standardization, a powerful message, but also a very important opportunity for all of you to seize. And looking forward, there will be for the next year, for the work program 2027, more than 220 million euros again at a pivotal moment to make it even further in terms of how we bring this research to the concrete results and towards implementation of 6G. Also there, AI, optical networks, wireless, ISAC, but also terrestrial connectivity are important elements. And altogether, we can see also with the Euro 3C project that was presented this morning that we have a lot of ingredients to make sure that this is happening very, very near in the future. So a lot of optimism from my side. I think a lot of also pride in seeing how this conference has evolved. I mean, it started 35 years ago, a bit as, a nice way to bring together projects. Now it is really not only on the European map, it is on the global map as a place where you join, you exchange with colleagues, but also you leave with new ideas. And I think that's what we want to bring in the future. So, ladies and gentlemen, to conclude, we call today the Tech Liberation Day of Europe because we have built already a basis through our digital rule book, but now we want to take our destiny into our hands and really make sure that Europe is the place to be as far as technology is concerned. It is the place to be as far as connectivity is concerned, but I think we can do even more, even better. And with this, I would like to really, again, congratulate the organizers. We will have also a transition in the conference, and I would like to thank very much also Luis Correa, who has served as the chair and steering committee chair for the conference for over 10 years. So Luis, thanks a lot really for your tenure, for the important work you've done. There will be a bit of a transition with Marco Junti from the University of Oulu, already in charge of the 6G Summit. He will, really now be replacing Luis. And I think we have also there a nice way to continue in this transition. I hope that EuCNC 26 will contribute once again, as the previous editions, to a successful moving forward in terms of research and innovation. But I also want to express the wish that today is not just a single event, it's the beginning of a new journey towards leadership, but also towards making EuCNC even more the place to be as far as connectivity is concerned. Thank you.
Thank you so much, Mr. Thibaut. Thank you for your vision and your insights. It's clear how important the policy framework is in shaping the future of connectivity in Europe. Thank you so much. And now we move to the broader European digital ecosystem, and building on that perspective, it's now time to hear from someone who has been very closely involved in connecting and representing the European digital ecosystem. I'm talking about Ms. Erzsébet Fitori. Let's welcome her with a big round of applause. We're all ears.
Good morning, distinguished colleagues, dear friends of the research community. Also a very warm welcome on my behalf to Malaga. Malaga, this historic city that is over 2,800 years old, and to this historic edition of the conference marking its 35th anniversary. Congratulations. And also it's very remarkable that we can gather here today in Europe over 1,000 delegates from over 40 countries. A very warm welcome to all of you. Whilst we are here with a lot of experience, a lot of knowledge in this room, many of you have worked on the previous technology revolutions that we have experienced. I think that this could not be a more important moment, not only the technology revolution, but also I think a very important inflection point in technology development for Europe and also globally. I really commend the inspiring title, 6G, Connecting Intelligence. I really think that the discussions, the technology, the demos that are present today could not be more forward-looking. And I think that it has been mentioned already today, but I have to remind of the really important context that we are in. A global race towards competitiveness, towards technology sovereignty, towards leading the technology race, where I think we have to build on the analysis and the diagnosis that Europe has to close its innovation gap and has to invest and focus on innovation in critical technologies. And if we look at what technologies those are, I think quantum, semiconductors, artificial intelligence, energy, robotics, sensing in space, advanced connectivity, 6G is of course one of those critical technologies, but very importantly, it is the foundation, if you like, the connective tissue building on which the others and the success of many of the adjacent sectors will build. When we look at the key technology areas of 6G, it represents a true paradigm shift. We are moving from connectivity paradigm as we know it today towards convergence, or I would rather say integration of communications, integration of computing capacity, artificial intelligence capacities, sensing and advanced positioning, and a network that is ubiquitous, that is literally connecting edge to orbit. I think that it is really important to recognize both the opportunities that this paradigm shift is bringing and also the opportunities. What is our challenge, building on Thibaut's speech? It is to ensure that the infrastructure, the technology that will be powering our digital society, our critical industries, which are globally competitive today, to remain innovative, competitive, but also sovereign. And increasingly, I think as it's very much marked by the package that is being released later today, technology leadership, mastering key components in the value chain, and often controlling them as well, will be very closely tied to remaining sovereign. So what do we do? What does SNSJU do in order to advance innovation, competitiveness, and also impact? As Thibaut has mentioned, we have now an impressive portfolio of 100 research and innovation projects, which are actually covering by now the full innovation stack, if you like. 100 projects that cover fundamental research to experimental platforms, but also large-scale trials and validation across the full stack, building ultimately the connected digital ecosystems that Europe will need in order to succeed. And to zoom in on the next steps that has also been mentioned already by Thibaut, where are we today very specifically in our program? We have a work program adopted for 2026 and 2027 with a very focused approach this year. We have just closed and will be soon evaluating our 6 call for proposals with 5 targeted but very important topics, including international cooperation with India, a CSA also for devices, but also experimental infrastructure and data sets for AI networks. We have just opened a new call for microelectronics for the front-end module, which is a very important and strategically key component of radio access networks. I think very much demonstrating how we are trying to reduce dependencies in Europe on foreign infrastructure, on foreign suppliers. We are actively working together with both of our members, the public side European Commission, and on the private side the 6G Industry Association, on developing a very ambitious work program for 2027, and indeed it will be a large one representing roughly 220 million euros of public investment. But we also look beyond funding excellent research projects. We actually measure and monitor the output of our projects at the program level. And I'm really proud to see that there are considerable achievements at the program level of the SNSJU, which really show how research and innovation can move towards industrial opportunities and industrial impacts. If we look at over 2,000 contributions to standardization or over 200 patents, but also I think several hundreds of use cases for verticals or the trials or indeed the investments in ensuring that our future networks will be sustainable, green, more energy efficient, are all being achieved by our projects. So I think it would be really worthwhile, and I invite all of you to look at also the exhibition. I will be actually looking at the stands with great interest to see in real life what these research projects are delivering. As I said, we have just closed our last call. We have a call for proposals on the front-end module open with 14 million euros of Horizon Europe funding. You have the opportunity to look at it carefully, and I invite you to look at it carefully on our website. The call is open until the 3rd of September. And to conclude, I think it is clear from everything that we see, all the discussions that we have had yesterday with representatives of governments, the remarkable package that we will see later on today from the European Commission, that indeed we are at an inflection point. We are going through a technology paradigm shift where actually 6G is becoming a strategic platform for connecting intelligence and more. It is vital that Europe continues to invest and lead through innovation, public-private partnerships, contributions to standards, ensuring that actually European values, the European vision, are represented in those. Through the SNSJU, Europe is transforming research excellence into real-world impact, industrial leadership, and also global influence. But I also think that we have to continue on the collaborative path with focus. We have to identify those points where we can still build on key European strengths, where we can actually create the levers for maintaining European sovereignty, and where we can actually ensure that research and innovation moves from lab to market. It actually translates into industrial capabilities, competitiveness, and societal values. I wish you an inspiring, a memorable event, and a very pleasant time in Malaga. I really hope to meet many of you during today at the exhibition floor or in the sessions. Thank you very much.
Ms. Erzsébet, I am convinced this conversation will continue at the other spaces and areas of this summit. Thank you so much for your contribution. It really helps us understand how the connection between the industry, the stakeholders, and innovation across Europe. And now let's return to that academic research and scientific side, which is at the heart of this summit. I'm afraid the rector of the University of Malaga couldn't be able to be with us today, but we are honored to have, on his behalf, Mr. Francisco Javier Lopez. He's the Vice Rector for Business, Territory, and Digital Transformation in the University of Malaga. So let's welcome him with a big warm applause.
So, hello, good morning to everyone. Ladies and gentlemen, my name is Javier Lopez. I'm Vice Rector actually for Technological Innovation and Strategic Projects since January. I was Vice Rector of Business time ago. And I would like, on behalf of the Rector and myself, I would like to warmly welcome you to the 2026 EuCNC and CG Summit. I welcome also our guests, invitees for the conference. And I will be very brief, I would like to use just a very few minutes to comment to all of you about our university commitment to education and research in communication networks and related technologies. The University of Malaga is a young university, still young, a little bit more than just 50 years, with strong educational and research activities across all fields. Social sciences, humanities, health sciences, science, and especially engineering. Since the late 80s, our university has progressively strengthened its commitment to engineering education through the schools and programs in computer engineering, telecommunication engineering, and industrial engineering. And in this sense, over the years, the university has expanded its undergraduate, master's, and doctoral offers focused on software, communications, and electronics. Today, the University of Malaga has around 7,000 undergraduate and master students in these major technological areas, hence contributing significantly to regional and national development, while also at the same time maintaining a strong international presence. The joint commitment of our university and the regional government has enabled the success of two major research institutes, both of them represented at this event this week: the Software Engineering and Technology Institute, ITIS, and the Telecommunications Institute, TELMA. Among many achievements, ITIS and TELMA has positioned the University of Malaga, without any doubt, among the top 5 Spanish research institutions in terms of funding as well as infrastructure for 5G and 6G research. This fact will be highlighted in this afternoon session dedicated to Spain's UNICO program, introduced by the Secretary General for Telecommunications, that as is accompanying us today. Let me be precise about the University of Malaga regional leadership in communication networks that can be better illustrated through these examples. The joint 6G research lab between Keysight and UMA opened in January 2025, a joint research unit with Telefónica focused on European research project, an agreement with Vodafone to promote 5G over satellite technologies, numerous collaboration agreements with leading companies such as Ericsson, DECRA, and Google, and also the strategic collaboration between University of Malaga and Malaga Tech Park, our scientific and technological park, that led to the creation of UMA Intech, the UMA Technological Innovation Office, for which I am director at this moment. And that includes milestone initiatives as the active role played in attracting IMEC, the world's largest independent research and innovation center for nanoelectronics and digital technology, that will come to Malaga soon, together with other institutions. On a different perspective, it is also important to highlight the participation of European 5G and 6G initiatives. To be more precise, UMA was a member of the 5G Infrastructure Association and the 5G Public-Private Partnership, and currently continues as a member of the 6G Infrastructure Association and the EuCNC joint undertaking. It must be highlighted that our university has participated in a total of 12 projects funded under this initiative that I just mentioned. Additionally, last week, the University Governing Council approved the University of Malaga incorporation into SLICES Spain, enabling our participation as a university in this major European research infrastructure, and obviously through the facilities and researchers of the ETIS and the TELMA institutes. I would like to finalize highlighting also that it is important, very important, to point out the university role in the organization of this event. Together with Telefónica, UMA has devoted all the necessary efforts to ensure its success. I'm sure you're enjoying that. In particular, we would like to, as a university, institutionally talking, we would like to acknowledge the leading organizational role played by ETIS in coordinating and supporting this conference, and particularly to Professor Pedro Merino as Technical Program Committee co-chair and leader of the local organization committee. To finalize, I just would like to, again, on behalf of the Rector and all the university community, to wish you a very successful event and also to enjoy Malaga and the area during these days. Thank you very much for your attention.
Thank you so much, Mr. Francisco Javier Lopez. Thank you for your inspiring input. All right, and now to wrap up this round of conversations and interventions, now it's time to have a look on the national perspective on digital transformation and connectivity strategy. A pleasure to invite Mr. Matías González, Secretary General for Telecommunications, Digital Infrastructure and Digital Security at the Ministry of Digital Transformations and Public Services. Welcome, Mr. Matías.
Good morning, distinguished guests, European colleagues, ladies and gentlemen. This is a really huge auditorium, very impressive. Welcome to Malaga, all of you. Welcome to Spain, and welcome to the 2026 European Conference on Networks and Communications, supported by the European Commission and 6G Summit. It is an honor for Spain and especially for me to participate in this premier global forum at a defining moment for the future of digital communications. The speakers that have spoke before me have already mentioned the crucial moment that we are facing in the coming months, years, and the crucial decisions that Europe has to make. As we begin this conference, our eyes are fixed on the horizon of 6G technology. We are moving rapidly beyond the abstract definition of use cases in, as we usually say, PowerPoint, into the technical realization phase of this technology and coming and producing real things, real functionalities for human beings, for societies. 6G will not merely be an incremental upgrade of data rates. It represents a paradigm shift forward, connecting intelligence. I think this expression has already been mentioned. It will natively blend our physical and digital worlds through architecture that features ultra-low latency, extreme reliability, and revolutionary capabilities like integrated sensing and communications. However, to unlock this future, we must look beyond traditional network design. 6G's success relies on a truly multidimensional architecture, where terrestrial networks seamlessly intertwine with space and airborne infrastructure. I think Thibaut has already mentioned that there is a need of different technologies. There is a convergence of different technologies in the current moment of the development. But this multidimensional architecture, I think, is crucial to understand the new capabilities of the technology that is at our doors. And this brings me to the core focus of my intervention today. I would like to focus on non-terrestrial networks, NTN. The realization of ubiquitous 3G coverage, reaching rural areas, maritime zones, and critical transport corridors requires a unified spectrum approach. Specifically, the 2 gigahertz band, the 2 gigahertz mobile satellite services band, has emerged as an invaluable strategic asset for Europe. It is the ideal spectrum for direct-to-device connectivity, allowing standard mobile devices to connect directly to satellite constellations where terrestrial networks are not present, where there are gaps of coverage in terrestrial networks. We are no longer talking about distant science fiction scenario. Today, limited commercial direct-to-device services are already being deployed in several countries around the world. And here in Spain, our industry is actively spreading this transition with pioneering pilots across different companies. Concretely, right here in Malaga, we can look at a groundbreaking reality. Vodafone, in close collaboration with the University of Malaga and different companies, particularly AST, Space Mobile, has established a landmark innovation center, particularly financed by a grant from the Spanish Space Agency. This hub houses a dedicated space to land gateway, specifically built to test, design, and validate open source hardware, software, and processing chips, the whole value chain. This is a clear testament of how Spain is translating global connectivity ambitions into local, cutting-edge industrial realities. It is precisely because of these tangible realities that last week's publication by the European Commission of the proposal for a regulation on the EU-level authorization of systems providing mobile satellite services, MSS, is so crucial. This proposal marks an ambitious effort to introduce highly centralized selection regime at the Union level. And I want to explicitly state the position of the Spanish administration, a general overview of our position. I'm not going to enter into any details, but a general valoration of this proposal. And it is very positive. Spain strongly supports the strategic pillars of the proposal that we have just known from the Commission. We share the goal of reserving a significant part of the band, 1/3, for secure hybrid governmental communication integrated services with IRIS² capabilities, or with IRIS² infrastructure. And we also support the reservation of commercial spectrum for new European entrants to diversify and enrich our supply chain and counter global monopolies. To maximize the success of this framework, Spain looks forward to a constructive dialogue of refining its implementation mechanisms. While the proposal reflects the forward-looking ambition of the Draft Digital Networks Act, we believe the most robust path forward is to let the co-legislative process within the Parliament and the Council naturally mature. In this context, Spain advocates for a balanced governance model, one that harmonizes European vision with the proven efficacy of national competencies, managing terrestrial segments, dealing with potential interferences and spectrum fee structures requires a deep connection to local market dynamics. Entrusting these specific responsibilities to member states is precisely what will guarantee operational continuity and investment stability needed to make 6G a shared European success. The regulatory decisions we make regarding this 2 GHz band over the next 2 years, leading up to the World Radio Communication Conference in 2027 in Shanghai, with many relevant points in agenda for the harmonization of direct-to-device connectivity in IMT bands, in terrestrial mobile bands, and the finalization of the DNA project will profoundly dictate the leadership, speed, and deployment of 6G in Europe. And this is because the player ecosystem has fundamentally been transformed. A few years ago, telecommunications was an insular and isolated world dominated almost exclusively by traditional mobile network operators. Today, the value chains and the technologies supporting these value chains have disaggregated. And it includes satellite constellations, satellite operators, hyperscalers, open source software developers, tower and fiber companies, among others. The value chains, cloud, AI, so it has not stopped to develop. In our European regulations, if our European regulations are rigid, or if they strip member state of the flexibility needed to foster local public-private partnerships, we risk stalling the market entry of these multiple and diverse actors. To win the global 6G race, our regulatory frameworks must incentivize this expanded value chains, encouraging flexible network sharing and vibrant industrial ecosystems. Ultimately, this spectrum and ecosystem debate is inseparable from technology sovereignty. This concept has also been previously mentioned by my predecessors here. Europe can no longer afford to depend on third country providers for over 80% of crucial digital infrastructure and cloud services. This is an imperative for democratic resilience. In February of this year, the Spanish government approved our strategic roadmap to accelerate digital sovereignty in Spain. Our strategy explicitly seeks to combat digital neocolonialism, which is the word that we have introduced for this growing influence of other countries in technology decisions in Europe. Spain views digital infrastructure as a public good that must protect fundamental citizens' rights. It's a critical asset. By ensuring that European traffic remains under European jurisdiction and physical control, we align directly with the broader goal of an open and, of course, secure European autonomous fabric. Spain is not participating in this debate theoretically. We have the ambition to lead by example through massive structural actions. From 2021 to the present, Spain has invested more than 200 million euros directly in 5G advanced and 6G research, development and innovation. We are a leading nation in standardizing and deploying advanced 5G pilots, establishing a powerful nationwide scientific and industrial infrastructure that now serves as our launchpad for 6G. The tangible fruits of these investments, the projects born from our ecosystem and the strategic milestones in our national program will be showcased right here in the conference this afternoon in a table in which I personally participate. So to end up, let us use these 4 days in Malaga to collaborate, to challenge outdated regulatory models, and to build a resilient, sovereign, and intelligent digital future for Europe. Thank you very much.
Mr. Matías, thank you so much. Thank you to all our speakers as well. What we've heard today reflects not only where we are in terms of technology, but also where we are heading as a global community. All your perspectives, it's clear that are aligned, and that reflects how important it is to be aligned when it comes to the future of connectivity and digital transformation. Before we say goodbye to this opening session, we want all of you to come here in the center for a photo moment. And all right, I don't know where are the photographs. There we are. Just in the center of the stage, please. There we have the photographs. And this, ladies and gentlemen, is the beginning of 2 intense days of exchanges, connections, collaborations, network, innovation. Only the beginning. All right. Thank you so much to our speakers. Thank you to all of you for being part of this opening session. All our speakers now are heading to a tour across our stands, but I will leave you on very good hands. You have two intense and very inspiring keynotes moderated by Ivan Seskar. Before I said goodbye to my side, I wish you a very inspiring and productive stay here at this year's summit. Thank you so much. See you.
Thank you, Romina. So, ladies and gentlemen, it's my pleasure to introduce our first EuCNC 2026 keynote speaker. His career spans nearly 3 decades at the forefront of mobile technology. After graduating from the Technical University of Madrid, he joined Telefónica in 1995 as a radio planning engineer. And from there, his trajectory reads like a map of the industry's most ambitious projects running across 3 continents. He led network deployment in Morocco, served as a director of access network for Telefónica Mobiles in Mexico, and as the CTO of Telefónica Mobiles Mexico, he oversaw the world's first transition from CDMA to GSM. As a CTO of Telefónica Deutschland, he steered one of the largest LTE deployments the mobile industry has ever seen. Today, he leads core transport innovation and ecosystem at Telefónica, where he's driving the transformation of the company's network architecture and technology strategy. His contributions were recognized as the Telecommunication Engineer of the Year award from the Official College of Telecommunication Engineers. In his keynote, he will share how operators are inventing core transport and edge infrastructure as programmable, scalable platforms for digital economy, and why collaboration across the industry is key to getting there. Please join me in welcoming Cayetano Carbajo to the stage.
Good morning. Thank you, Ivan. Well, as you heard from the presentation, I have been more than 30 years in Telefónica, and I have had both operational roles as CTO of Germany or CTO of Mexico or Morocco, but also corporate roles leading innovation and standardization for the network in Telefónica. Then I think I can provide you an angle of what we need of transforming our network, both from operational side, but also from innovation and standardization side. So it is my pleasure to share with you my ideas or our ideas about how we need to transform the networks. Well, the advantage of becoming old and having 30 years in the industry is that I have seen many transition of technology. I started to work even in analog, so I saw the transition to GSM in mobile, and we have seen all the evolution in mobile services, as well the evolution of fixed access, in which, well, Telefónica has been leading with the full deployment of fiber here in Spain, shutting down the copper already. But the key thing is the evolution. What we see is that when we evolve for transporting voice and then bits, now providing services, we heard about gateway to the intelligence and bringing the compute closer to the customer. What we see is that the value that the telecom network are providing are increasing continuously. And we are making a higher value to the customer and the society, making visible all the value that the telecom network can provide to the society. I think the transformation of the network should increase this speed of bringing value to the society. Well, we know that we need to transform, but what are the pillars of this transformation? In Telefónica, we think that we should base this transformation in these 4 pillars. The first one is AI and cloud nativeness. When I say cloud nativeness, I do not mean that we have to bring all our network function on top of a public cloud or something similar. What we mean is that we have to take advantage of all the cloud technology in terms of automation, resiliency, and flexibility. For instance, implementing in-service software upgrade and being able to change the software of our network without taking out the traffic, or having automatic testing and automatic onboarding, having CI/CD pipelines. These kind of things we are already introducing in the network. For instance, in the core network, we have a lot of progress. In some other network segment, we are progressing, and we have still work to do. But this is a key thing. So this flexibility and automation of the cloud, we have to implement in the network, in the transformation. We are doing this now, but this has to be increased in the transformation. As well, AI nativeness. We believe that the future of the network, AI will be a relevant technology that will help us not only to increase the level of automation, but also to deliver new services. And the network has to be designed taking this into account. The second pillar is openness and disaggregation. We believe that having open interfaces is reducing the locking and dependencies, but also is allowing us to increase the level of automation. An open interface is easier to be automated than an interface that is proprietary. So we believe that disaggregation and openness is a key element for the network transformation. Another pillar is automation. Normally we see automation as a way of increasing efficiencies, but it's not about efficiency, or not only about efficiencies. It is not that we have to automate the network to make it more efficient, that as well we should do. But it's also to increase the level of quality. A network that is fully automated provides better quality to the customer, and also hide complexity and make launching new services easier. So in order to monetize the possibilities of new technology, it is better to have the network fully automated. And finally, trustworthiness. By trustworthiness, we believe that the network is more and more relevant for society and for customers. When the telco network is shutting down, the country can be stopped. So the network has to be trustable. Has not to be only secure and safe, but also resilience, has to respect privacy, has to be sustainable. We will see this later. But I think when thinking in the transformation of the network, we have to take this into account. So we need to transform the network. We should know to where we have to go in this transformation. It is important to know what are the services that we will provide with our network. The problem is that in our industry, we have a lot of uncertainty about the services that we will provide. And this has been historical. I mean, before beginning of short video and TikTok, we have no idea of that. Or before beginning of Facebook, that has impacted that much the traffic profile of our network, we didn't see this happening. In general, services are coming from outside of the telco network in many times, also from our network, and there's a lot of uncertainty. In general, our industry is very dynamic, and we are changing, and we are adopting new technology, and we are providing new services. Personally, this is one of the things I like the most about our industry, the need of keep learning and updating. This is challenging, but it's motivating. I like a lot. But coming to the services, there's a lot of uncertainty. The key message that this has is that we need to build network that should be flexible. Flexible to be adapted at the new services and the new traffic profile that we will have. We are guessing some of the services that we will provide in 5 years or in 10 years, but we have no certitude. And then our network have to be able to react to the different traffic profiles of the different services. So key element of the transformation has to be flexibility. Let's talk about AI. Well, as you saw in the opening, AI is impacting a lot of our technology. And maybe there's a bit of hype of AI, but in any case, even with the hype, the impact of AI will be massive in all the society and also in telco. And for illustrating this impact, I selected 3 numbers. So the cumulative investment in AI infrastructure from now till 2030 will be $2.5 trillion. Okay? So this is massive investment, massive evolution of technology, and we will do many things with this. This investment will be done not always in the places that data center used to be, because there's a scarcity about electricity. So data center will be installed in places that has to be communicated. The topology of the network will change, and the east-west traffic will increase, and this will impact our network. So the scarcity of electricity will need that we will transport the data of this data center to the customer. But also it will be needed, mainly because of AI inference, bringing closer to the customer the inference. And then we are working in edge. It is expected that from now till 2034 in Europe, we will invest 50 billion euros in implementing edge computing services, what is a lot. So clearly, AI is impacting telco network. It's impacting society, but also is impacting telco network. For impacting telco network, we have two angles. One is, what can we do with AI for automating the network, what we call AI for ops. The other thing is how the network has to be adapted to provide AI services. If I start by what are the things that we can do with AI for automating the network, AI is a key element for increasing the automation and the network autonomy. I think there will be things that without AI, we will not be able to do if we want to have a really autonomous network. We are working already in digital twins, in anomaly detection, in automated root cause analysis, and there are many things that we can do that will help us to increase the level of autonomy of the network. But also, in my opinion, this movement to use AI for operation will modify completely the way we are operating the network. We will have a complete new operational model of the network. There are things that we will do in a different way with AI. There are processes and flows that maybe we are changing completely, and there are things that operator we are not doing internally that maybe with AI we can do internally. So the operational model of the network will change a lot. For all this to happen, there are different requirements. Of course, security. We need to, if the network is operated, and we saw before that network has to be trustworthy, the level of security of the agent that is operating the network has to be high. Also, in telco, we have a problem. We cannot share the data for training the models. Federated learning is key. I mean, we need to train the models for AI with the data of the network without exposing outside the data of the network. But we need to have the benefit of scale in this training. So exporting the parameterization of the algorithm of the model and federating the learning of different networks is a must. So federated learning for telco is very relevant. And maybe we will need a telco model. There are things that are quite specific of telco, and latency and speed are very relevant. So maybe we need small models that react quickly for certain function in the telco. So this is a requirement, and many of us, we are working on this already. If we go to the other side, I mean, how the network has to change to deliver AI services, the first thing I can tell is about the impact we have today. We have not yet a massive impact of AI, or at least we cannot see so clearly, but there are some trends. For instance, uplink is growing faster than downlink when AI is in the flow. For instance, the session of this, the length of the session when AI is included are longer than when it's not. And the topology of the traffic is different, and the number of connections is different. So this is starting, but I think we will have more changes. We will evolve of connecting person or machines to connecting agents. the number of connection and the way the network will manage that will change. And this will be a massive change for our network. But also, what is relevant is that AI will offer us the opportunity to sell to our customer, to provide our customer new services. We will include compute in our network, and we will have a distributed intelligence, distributed inference. And this will change the topology of the network. This will require new capabilities for orchestration. This is a clear path of transformation of the network that we are already working on it. But there are some other things that we will have to improve. With inference, it's likely that many of the services will need reduced latency. We need to work for reducing the latency of our network. It is expected that the uplink will be more relevant with AI, so we need to improve the capability of our network for providing uplink transport. And as I said before, there will be a lot of need of orchestration. We see very clear the idea of continuous compute, having compute in the customer premises, in the edge, and in the data center, and then the orchestration will decide measuring the performance of the network, knowing the capability or the compute request of the customer, and the best LLM for this query, where to put the inference, if in the customer premises, in the edge, or in the data center, and moving this dynamically, doing automatic onboarding of the application that will need this inference. I think this is a must, and this idea of continuous compute, continuous inference, is a way that we will transform our network. We are working already on that. We are working on that, and I would like to mention this project, IPCICs. Telefónica has deployed 17 edge locations, and we are working together with other colleagues, other operators, in having this European cloud edge continuum. It's not only the idea that I mentioned before of a compute continuum with orchestration in our network, but also being able to federate without other edges. And we have already pilot working of federation. And we have commercial service here in Spain of an orchestrated edge. We have 17 locations, and this is up and running. You can contract these services for Telefónica today. And this idea of orchestration and federation, it is relevant. It's coming from these EPCICs. But I mentioned before that the network has to be resilient, and that it is important the level of automation. A couple of data. Majority of our big outages are coming by human mistakes. It is not because of software bugs or problems in the hardware or energy problems. Majority are coming when we do a change in the network. It's not a problem of Telefónica, it's a problem of the industry. When we do a change in the network, the probability of having a mistake with the complexity we have in the network is big. So if we automate, we will reduce this significantly. We will increase the level of quality. Also, the services that I mentioned about orchestration, all these things, they are complex. And if we are not automating them, it will be very difficult to deliver these services to the customer in an efficient way. We need automation for this. And for sure, automation drives efficiency. So automation for us is important, and we have to include automation in the transformation of the network. This is a key pillar, as I mentioned before, and has to be in our focus, has to be in our target when transforming the network. In Telefónica, we take automation very seriously. Telefónica is one of the few operators that we have committed with the analysts and shareholders to reach a certain level of autonomy. So we committed to reach the level of autonomy 3.75 in 2028 and 4 in 2030. This is referring to the TM Forum autonomy level. Okay? For doing that, we have implemented projects since 2021 that impact all the network segment, I mean from access, transport to core, and even customer premises. and also all the functions. It's not only the operation, it's planning, it's technology, it's operation, maintenance, everything. We have this multi-year program with a very wide impact in the organization. It's not only about implementing new technology for doing that, it's as well having the right skills and the right culture for increasing autonomy, and we're working on that. This has to continue, and as you see, we are above layer 3 already in Telefónica, but the target of level 4 needs transformation, needs a lot of AI, but also open interfaces and openness is needed if we want to reach this level of automation. This has to be as well a driver for the network transformation. Let's talk about mobile network evolution. I think we are in a conference in which we are talking about 6G, but let's see what can we learn from 5G SA. It's good to know and learn from the history of the previous generation for building a new one. So in 5G SA, we finished the standardization in 2017, and we deploy 5G NSA soon in 2019. Problem is that today, 5G SA, 5G standalone, has not been massively deployed, at least with massive penetration of devices in Europe. In some other geographies, we have more penetration, but not in Europe. The maturity of the device till now has been poor. Now it's improving a lot. We have no proper solution for voice. The majority of the network are using fallback today. And the key thing is that we have no new services that is massively adopted in 5G SA, meaning we have no many services that we can provide with 5G SA that we are not able to provide it with 5G NSA or 4G. Okay? So key monetization services, key use cases are not widely deployed. For sure, we are exploring and we are investigating slicing, and we are commercially exploiting that, but we are touching the surface yet. We need to do many more things to monetize 5G. Okay? From this history, my learnings are the shortcut, like 5G NSA, has been a mistake, and I think we all agree on that. The big revolution in the core, the movement to the service bus architecture, was a very good idea. We increased the level of automation and cloudification with that, but has not delivered many new services. Some, but not many. Okay? The voice solution should be there from the beginning, and the device maturity and the ecosystem maturity has to be taken into account when planning. Okay? With this into account, when starting the 6G, we made ourselves several questions. Okay? Now there's no more question because we are already working a lot in 6G and we are standardizing, so the train left the station already. But I wanted to bring this question because our question that an operator has about 6G. The first idea is, do we need another G or we need a smooth transition? Do I prefer to call it release 21 or 22, or do we prefer to call it 6G? Do we need a 6G logo? Because having a 6G logo is not improving the customer experience. What is improving the customer experience is the real performance of the network and the new services that we are able to deliver with 6G. Do we know enough about the impact of AI for already standardizing 6G? Another question that is, we will be able to do a standard that we will implement more than 20% of functionality that is in the standard, like we have in 4G or 5G. So we have huge standard, and then we implement a small part of the standard. The reason of this question is not about stopping 6G now, for sure not. We need 6G, and we have to go for that. The message is, when implementing a new generation and when standardizing a new generation, we need to do that taking into account the services that we will provide to the customer and the improvement in not only in performance, but also in the service and in the value that we are providing to the society. The capability of monetizing the new generation has to be a key focus when transforming the mobile network and evolving to a new generation. This is the key message. Talking about monetization, as said, the evolution has to be driven by use case and the monetization capabilities. We have, when standardizing and when implementing 6E, take into account what are the services that we'll deliver. Okay? Differentiation per customer and per service is a must. I think best effort will not be good enough effort anymore because there are services very demanding. So differentiation is a key element. There, for sure, we have to fulfill regulation, and this regulation that allow some differentiation and doesn't allow some other, but differentiation will be present in our network. And the capability for differentiation has to be key in 6G. Communication services is a key area for telco operator, and there's a lot of potential for innovation there. We have not been very active in communication services, and I think we can monetize 6G with many of the communication services that we will be able to implement, maybe on top of IMS, like the services that we have already in communication. Okay? I said at the beginning, for monetizing and for having the right services, it's key to have a network that is flexible to react to the new services. We don't know what are the services that we will be able to provide, so we need to have this flexibility for reacting and adopting 6G to the services that will come, and will come very likely with the adoption, the massive adoption of AI. And finally, we have a lot of bottleneck from devices and operating systems to deliver new services. Even if we include in the standards certain requirements for the devices, not always they are fulfilled, and the control of operating system and devices for the services is reducing the capability of innovation. So we need to solve that in 6G. So as you see, these points, these measures, these proposals are aiming to increase the level of development of new services and the capability for us to monetize the network. As a message for 6G, the standardization, that by the way has to be global for sure, and the innovation in 6G should be oriented to new services and use cases. This is a must, and we have to learn, and we have to take into account what are the services we want to provide and what is the ecosystem that we have for delivering these services. An ecosystem meaning not only the network and the devices, but also the application and the new services. As part of the innovation effort, use cases has to be taken into account. In our innovation activity, in network innovation activity, always we have use cases and new services, and this has to be a must. And this has to be transported to the standardization SDOs for having this standard, taking into account the new services. What else? I mentioned about trustworthiness. As said, the network are more and more relevant for the customer, more and more relevant for the society. I think Thibaut said today that when telco networks stops, the whole country stops. And it's true. I mean, there are many things that our customer do with our services, and if we stop, the whole society stops. For this, it's important to have a network that the customer can trust. And we have named this as trustworthiness. And trustworthiness doesn't mean only security. For sure, we have to have security, but also we have to have privacy. And we have to have resilience. As part of the definition of trustworthiness, we include usability. The network has to be able to be used by everybody. And integrity of the data, integrity of the communication. And the network has to be sustainable. These are the key elements of trustworthiness. That is very wide, as you see. Okay? In Telefónica, we're taking this seriously. For instance, when talking about sustainability, Telefónica has been nominated the second more sustainable company in the world. Not telco company, but overall. Okay? What means that we are taking serious sustainability. Regarding security, for sure, we all are working for having network secure and safe. We see as something worrying the evolution of quantum technology. Quantum technology is bringing us a lot of possibilities, but also a threat, that is the security and safety threats of quantum computing power. We have implemented in Telefónica a center of excellence in quantum technologies that is not only focused in security, but we're working a lot in security, both in quantum, post-quantum security and also in the quantum key distribution for encryption, because we need that this will be key part of our network in the future. We are worried about privacy. In Telefónica, all the service we design has privacy per design. So before defining the service, privacy is taken into account. And for sure, because of security, we have zero trust. When talking about resilience, we are implementing, as every operator, the network with the given redundancy and resilience, but also for us is very important automation. When increasing the level of autonomy, the resilience of the network will be increased. With the effort we are doing with the autonomous network journey that I mentioned before, the level of resilience is increasing because we have less outages coming from operational problems. And finally, another aspect that we need to have when talking about the transformation of the network is sovereignty. I think Thibaut mentioned sovereignty as well. But we need to understand sovereignty not as isolation, not as autarky. We need to continue using global technology. We need to continue having global standards. And the sovereignty doesn't mean that 100% of the element of the network has to be European. The sovereignty means that the key services has to be provided by European companies. That European company has to have the control and definition of the technology. That we have to have the transparency where the data is treated and where it's stored and is transported. And we have to have the integrity of all this connection. So we have to have the power to decide. When talking about sovereignty, we think that we need to take into account a multi-vendor scenario, disaggregation and openness, for not being dependent only in one technology or one provider. We need to have the measures to control the network and the access to the network. We need to have the ways for assuring the transparency and the storage of the data. This kind of things is where is making clear the sovereignty measure we have to implement. We have European mechanism, and in the slides you can see some of them, and even innovation is a key part of sovereignty. So summarizing, I think sovereignty is relevant, and unfortunately in our world it's more and more relevant, but cannot be understood as isolation. Okay? So we need to work for making our network less dependent and more sovereign, but not isolating from the global technology. And to finalize, I would like to go for a call for action. I think for our society, the telco transformation and the evolution of the network, and also the AI, should be set as strategic priorities. I mean, the society will be very impacted with this transformation, impacted in a positive way, and we need to see that as a strategy. The more benefit the telco network and the AI will bring to the society, the better. We need to put focus on that. For this, it's important to provide scale to the telco business. One of the problems we have today is that we cannot do some of the things that we have, and we are more dependent for other regions because we have not enough scale. And the automation of telco business is huge. We need to have the right scale for implementing this changing. I think we need to assure that European has a leading role in standardization. We had in the future, at least in some technology, I remember the times of GSM, but we need to have a leading role in standardization. This doesn't mean that we need European standards. Standard has to be always global. But this means that European companies, we should be leaders of the standardization, and we should be very active, more active than today in SDOs. And this is key from my point of view. We need to provide continuity to the European efforts for innovation. SNS is a very good example. I think we need to keep, maintain, and increase this innovation effort. This is a very successful experience, and we need to continue. And we are working, the public and the private world, very well together, and we need to continue doing that. And the success of initiative is proven that it is a way. We need to keep, we need to increase this effort, because the gap we have in certain areas is big, and we need to push for that. And finally, from operator point of view, it will be very relevant to accompany the innovation with first deployments. If we have an innovation for new technology or new service, and it is not clear the market traction, and we have doubt about the implementation of this solution in the network, then the innovation will take longer for arriving to the customer. And I think example that EPCIC's project, in which we have been able to deploy, in this case, edge nodes without having the market demand yet, but is helping us to increase and grow the ecosystem and the demand, are very good example. So the key thing would be that for those areas in which there's no still market traction, help in deploying in the network, in production, the new services and new technology is the positive measure for bringing innovation closer to the society. With this, I finish my talk. I don't know if we have time for questions or...
Yes, but people have to yell, so maybe we can have a time for one or two questions. Question, anybody? Please go ahead.
Thank you very much for this presentation.
We have a mic.
Perfect, and it's working. Thank you very much for these insights. We already discussed in another setting yesterday about the standardization issues that we face, like ETSI did a good analysis, and they found out that most of the standards are in fact not driven by Europeans, even if we are working hard on that. Do you have any thoughts on that, on how we can improve that in reality, like tangible actions that we could do?
Thank you for the question. I think there are a couple of things. First thing is simplicity. As I said, there's a percentage of the standards that are never implemented, so we need to simplify. And we need to, if we have a way of doing something in the standard, let's keep the way. Let's choose the optimum one and let's go for that, and not having so many options. This is key. Simplicity is a must. Second is, when standardization happens, we need to think in the final service, and we need to take this into account more than we have today. And I think this is not happening. This is key. These are my two measures. And maybe a closer coordination of all the elements in the standardization bodies. It is easy to say, but IPR are making it a bit difficult. But I think we need to have more dialogue and having a closer coordination, all the members of the SDOs. These are my three measures. Any other question?
Any other question? And this has to be the last one because we're running out of time. I'm sorry about that.
Yeah, thank you. I appreciate it. My name is Mitch Zheng. I'm with Next Generation Alliance. My question is, when we enter the 6G era, right, will the network continue to be a big pipe, or once we add an intelligence of that, then operators will make this intelligent network and start maybe have some monetization models based on that. The reason I say so is because in 3G, we lost the opportunity to charge data as water and electricity. Mm-hmm. So now we're going to change this in 6G. Thank you.
I think the bet is that we, with 6G, will transform the network in many more things than just a pipe. I think integrating the compute and artificial intelligence in the network is key, and I think 6G will help us with that. I see the future of 6G with the capability of not only deliver the right connectivity, but deliver the right compute in the right position, with the right LLM, and with the right application and service. My point is, when an agent will request certain compute, the point that is, or the area that is connecting everything is the network. And the 6G network will be able to measure the time to first token or time between tokens or many things. We will be able to measure the LLM performance, and we will know what is the application and the LLM or compute needs, and if there's any requirement of latency. So I see the network as a bit orchestrator and intermediation between LLMs and end customer delivering this service. This is easy to say, but difficult to implement, but the bet should be there. And I fully agree with you that we should aim for this kind of embedded intelligence in the network for increasing usefulness of our network and also monetization.
Okay, thank you very much.
Thank you, my pleasure.
For a great keynote. I didn't realize. Oh, okay. So wait, we have to present for you. Cayetano, we have one present for you. So I was just told that we are supposed to. Yes. Thank you very much.
Thank you very much, Juan. Thank you.
Okay, our second keynote speaker is someone I'm really delighted to introduce, not only as a leading voice in mobile research, but also as a colleague who I have the privilege of knowing for more than 30 years. Dr. Magnus Frodigh is the Vice President and Head of Ericsson Research, where he leads the company's long-term technology research, its collaboration with academia and industry, and its contributions across Ericsson business and product development. He holds the master's degree in science from Linköping University of Technology and a PhD in radio communication systems from Royal Institute of Technology in Sweden. And he's a fellow of the Royal Swedish Academy of Engineering Sciences. Magnus joined Ericsson in 1994, and over the past 3 decades, he has held senior positions across research and development and business product management through each generation of wireless technologies, starting with 2G and now coming into the 6G. In his keynote, he will lay out a vision for a 6G intelligent fabric and open, secure, and interoperable infrastructure where autonomous AI agents collaborate at machine speeds. He'll also make a case for a broadband international collaboration needed to turn that vision into trusted real-world infrastructure. Without further ado, welcome Dr. Magnus Frodigh.
Yeah, thank you so much for that introduction, Ivan. And I think it's a good opportunity now for me here to connect the dots a little bit and talk about the intelligent fabric. That is exactly what all the morning here has been all about, I think. So how will the AI functionality, the physical AI, be using or need to use the connectivity, and how will it then connect to the compute? So we talk about this intelligent fabric where we have the AI functions, and here we are already seeing them today, of course. We have the AI assistants, we have the agents, which gets more and more sort of environmentally sort of understanding, awareness. We have the AI glasses on the market, the augmented realities are around the corner. We are now very, very excited about the physical AI type of use cases. And that will lead to a lot of traffic in the networks, of course. There will be agent-to-agent communications and agent-to-humans. And there are beliefs that the future traffic will be dominated by agents talking to agents, right? So this is a huge shift we have in front of us. And you can have the humanoids there doing your dishes, you can have logistics, the taxis, autonomous taxis we have in many cities already, right? We have the drones that could be used for transport, of course, but it's also a threat that needs to be, so the detection of drones is, of course, important. We have these virtual meetings and the glasses. So all of this is just around the corner. So what will then these physical AI use cases really then mean? Obviously, it will need this sort of combination of the compute and the connectivity. And as talked about here before me, the connectivity will then be able to move workloads where you have the compute capability. It will be able to move your massive sensor data to a place where you can sort of use that in your algorithms or AI tools. This would lead to increased uplink requirements. Already now we are seeing a little bit of increased uplink. I will come back to that. But of course, with AI glasses recording everything you see, right, and that video prompting then in uplink will of course create a lot more traffic. In order to get this more conversational feeling with your AI assistants, of course you would like to have a bounded latency. But all of these machines communicating, of course, the latency will be key. And this depends a little bit on how the architecture would look like, where you will have how autonomous the device will be and how much you're moving the agents and the compute and memory out of that device. And of course, if you should be able to move out a lot of things from the object that should be autonomous, the more critical it will be on the delays. And there's of course a lot of advantages of doing that, because the power constraints environment in the devices you could offload compute into the edge. Reliability, we touched upon reliability here just before me as well. And a lot of these things will be very sort of critical, right? Safety critical. So in order to be able to trust these things with more and more advanced capabilities, the trustworthiness will be absolutely key. That's of course another sort of opportunity as well, to build networks deployments with the high reliability. That will of course come with a cost, and a lot of new functionality needs to be provided in order to minimize that extra cost. But it's still so that it's something that needs to be monetized. If society would like to have this resiliency, then of course it has to be sort of monetized somehow. There has to be a way to get sort of return on that investment. And then the coverage, of course, we see that now we integrate the satellites, so of course we will have much better coverage, you could argue. But it's really important to have coverage in the right area for that particular application. If you just run something in your home, you need 100% coverage in your home. If you run a smart city, you would like to have coverage, of course, in the city. For the autonomous vehicles, yes, you need outdoor coverage at least for the complete area where they operate, etc. So it's all important characteristics, and all of these are also fairly expensive, right? So back to the fact that we need to be able to monetize these new solutions. So I talked about these use cases. So we have the AI glasses, or you have first of all, we have the smartphones, of course, and we have the AI assistants already on the smartphones. Then we will have the AI glasses, and we have the augmented reality, which will make it much more advanced. Then we are connecting laptops, and not connecting to Wi-Fi, connecting to 5G, and with the security identification and everything. In order to adopt such solutions, of course, you need coverage for these. And then the cars, And this will, of course, be unevenly distributed. So looking at the global average numbers, traffic will not be seen. But in a particular city where you have the self-driving taxis, you get a lot more data. And then the agents, we are sort of talking about agent to agent, and we are all, I guess, impressed what we are creating agents. We can get agents to do things for us in our sort of professional lives, but that will, of course, move out in the society. And there is a huge investments in the different humanoids that are improving very quickly, and they are doing more and more sophisticated things. And we can already now see this uplink versus downlink. So if you look at, starting with the right graph here, these are measurements from the last 12 months, looking at traffic in networks. And then on the dashed line there is where you have an equal growth, uplink and downlink. So most of the networks now, the uplink is growing faster than the downlink. So we can already see that in the networks today. And if you try to look a little bit on how the traffic will evolve, we are in this sort of traffic sort of doubles total traffic for every 5 years approximately. And there's been a slower growth now. Perhaps we are seeing a little bit increased growth rates lately. So perhaps the growth rate is going up. But the uplink will grow much more. And here you can see how the proportion is now on the downlink uplink split, right? And how it will then evolve over time. And it's not a 50-50 there on this yet, but it will move towards that. And that will be a major change, to have much more uplink. So this will put big requirements on the networks, and all the innovations we can do in order to improve uplinks will be very, very valuable. So, talking about the compute, and this is of course very, very central, because we need all of this compute, and today you have compute in the device and you have them in the data centers. But we have been talking about edge compute in there, what to do in between. And I think that the physical AI use cases are providing so much value that you can then allow the investments also in the compute infrastructure. This is, of course, a big investment, and now we are into a second wave. I guess there were quite a lot of investments in edge compute before, right? And then this has not really been giving it the right return on these investments, but now we need to look at it again and now explore the possibility. And I think you can look a little bit on the numbers here. Perhaps we have 1 million subscribers out there. We could have 10,000 base stations. There could be 10-ish central core sites, and we might have one big data center, looking at this as one country operator perspective. And then it goes from how much power you can use. In the device, it's a few watts, right? If you are in the base station sites, it's a few kilowatts. So we are still very, very limited on what you can put there. And then if you move up in these more core sites, then you can have sort of megawatt. You can build a small edge data center there. Or if you are then investing in one big place, then you can have 100 megawatt or even more, right? So there is a very important thing to consider, how much power you can spend depending on how far you put things towards the distribution and towards the edge, or even towards the devices. Then, of course, there are very different devices. It could be a self-driving car, which has a lot of capabilities, or it could be one of these glasses, right? So, of course, depending on the use case, that will put different restrictions on this. And the further you push it out, the better latency requirements you get. You can also avoid moving data large distances. You can preserve privacy and so on. So there's a lot of things speaking in favor of pushing things further out. And all of these physical AI applications they are sort of acting on data, which by definition is local, right? So if you're controlling the traffic in the crossing, it's really all the data from all the cars and all the environments, all pedestrians that are around that crossing, which is relevant, by definition local. So it's a lot of advantages if you can push out the physical AI functionality in a more local way. So, focusing a little bit on 6G then, which we now have the different generations here. It has been an amazing journey, right? And I think there are big steps in all of these, but the business models really takes 20 years to evolve, I think. So the first two were on voice, the third and the fourth were on the mobile broadband and the app economy, and now we are in this fifth and sixth. And 5G has, in a very good way, opened up the possibility to address a lot of different things. The good news is, of course, that we have built out the 5G coverage, and that has been driven by the extended need of mobile broadband traffic. So 5G has been a capacity boost in a very cost-efficient way to providing all of that extra capacity that we need. And with the traffic growth we foresee the coming 5 years, I think we will start to get out of that capacity boost in the next 5 years. So we will need more capacity as well, right? But we really need the more sort of capabilities that 5G have started and that we will now extend into 6G. And one thing, you can look at what the network platform then will provide. It will provide this cyber-physical world. So it has the capability to take the massive sensor data, move that into the digital domain, and then from that you can sort of identify, you can learn everything about the physical environment, all the different objects that have their digital twin can live in this digital representation, and the network then can move all over that. And when you have that, all this data in learned models in the sort of the digital domain, you can start to predict what will happen, you can start to simulate what will be happening, you can take different actions, and you can figure out how you should control the situation, and then you can send all the activation data down to your, if it's self-driving taxis or whatever it is, right? So this is really sort of the overall picture. And from a network evolution point of view, how do we get there? And here I think it's very, very key that this is an evolution. And we are now, as said before here by Telefónica, the non-standalone was not a successful move, right? It was a very sort of urgent to get the technology on the market, but the core networks were not really ready, so it was decided to launch the 5G to connect with the old core. And then you get this 5G SA introduction, which is then sort of a transition in itself, which is very sort of difficult. Then we will have more 5G advanced functionality, and now there is momentum. We're getting out of that trouble now. So now is the SA is picking up, there will be more functionality in the networks. And this must now lead that we are starting to get the early adopters, that we need to evolve the business models in order to then get in the situation where there is opportunities to invest in 6G. It fills a very sort of clear gap, and you can get return on that investment. So I fully agree here. And so to avoid this shift of core networks, the idea is that we will take the 5G core, which is now sort of being established, invested in, that will continue to evolve. And we will be able to add functionality on that. And gradually it will be sort of the 6G core network. But there will be no sort of backward compatibility break or anything. All the 5G devices will be able to continuously connect to this. All the new 6G devices coming to the market will connect to one and the same core. On the radio side, there will be a compatibility break, right? And this is needed because you would like to be able to change some of the signaling. You would like to optimize different things. You need to redo a few things. I'll come back to that. And so there we will have a shift. And then in order to make that feasible, of course, there will be new frequencies for 6G, so you can put a new technology in the new band. But you also would like to, in a smart way, reform your existing bands. And then the multi-rate spectrum sharing is the key thing. So you are able to gradually transform. So you can have one system then that from millisecond to millisecond can decide if this should be a 6G signal or a 5G signal. We had this already from 4G to 5G, but it was not sort of in the standard. It was a little bit of an afterthought. It didn't have the right efficiency, but now it should be integrated from the start with very little extra overhead. So the frequency map is then important, right? And I would claim that when we are moving now, we are using up 5G capacity as we speak, right? And towards the 2030 timeframe, there will be a need to start to invest in even more capacity. And then you also need new spectrum. And it looks like that the centimeter wave is starting already from upper 6.4 to 7.1 gigahertz is a band that will be available, most likely in Europe. We are seeing that band and more being available, perhaps India, China, and then US have a little bit of a different setup, I think. So it looks like that will be a main sort of introductory band for 6G. But this is quite high in frequency, right? So of course, with the same size of the panels, you can put even more antenna elements, so you can increase the beamforming gains to compensate for that propagation loss, right? But the important thing is really to be able to use all the different frequencies. So then you would like to gradually then introduce 6G also in your low and mid-band frequencies. And in order to make sort of these monetization possibilities, you also need to be able to expose what you want to sell, right? So if you want to be able to sell a quality of service slice, it has to be exposed. You should be able to order that and get then exactly the type of performance that you are ready to pay for. Or you should have data from the network itself. So the network is a source of data. And then you, of course, think about the sensing capabilities. That will be clearly a source of data, but I think we have more data in the network that could be valuable for applications. Positioning we have had for quite some time, but you can also think about time, exact timing of things, etc. So there's a lot of possibilities. And the idea here is to have this exposure, the APIs, out of the network. But I think this will evolve. I think you will have agents in the devices, in your network, in the sort of in the ones that provides the service, and there will be agents communicating with each other, and the network will also be seen as an agent or multiple agents. So it will be an agent-to-agent communication where the network agent then provides more data, if so is needed. It could take commands of executing communication between different devices, moving things to another place for compute reasons, etc. So I think these APIs will be there, of course, but it will evolve into some more agent setup, I think. We also would like then to 6G to take it all, so to say. We would like it to be from day one capable of everything, right? So when you are moving into 5G and then into 6G, and then you have 6G for 10 years and you would like to reform or sunset some of your old technologies, you should have everything in that 5G, 6G family, right? So we really would like to offer a scalable 6G RAT that sort of takes all the different communication needs. Perhaps this ambient IoT, where you have zero power, zero cost, basically could be an exception. Difficult to get that integrated into that picture. So, and then of course we will build on the 5G NTN and make it fully integrated now in the 6G. We have a lot of fixed wireless access in the networks In some networks, it's more than 50% of the traffic goes actually to the households connecting with 5G. And in the beginning, this was a nice way to sell a bit of your overcapacity. But now, with such a significant part of the traffic, it needs to be optimized. So optimizations in order to get more efficient fixed wireless access is, of course, highly needed. And then we are adding sort of the sensing piece here. But there are, of course, more technologies here in the 6G now. Study item is ongoing. We have everything on the table again here. I think it looks like to keep the basics of the 5G with OFDM and the numerology, etc. That's, of course, a key thing in order to do this multi-rat spectrum sharing functions. But the MIMO will go further. We will have even more massive MIMO, and we are also looking in more distributed MIMO schemes. AI will be in the devices, in networks, and we will add more and more of these. I will have a few examples on that shortly. Energy efficiency, here I think there is one innovation is to split the signaling between the idle mode and active mode. So you can optimize them separately. So you can really go in deeper sleep when you are in idle. And there we also have ideas with wake-up receivers, etc., to even more save battery on the device side. Then one important thing, which is really one of these things which is not backward compatible, right? And that is the uplink-downlink decoupling. So you should be able to select different bands for your downlink and for your uplink. So typically, I guess you will have coverage issues in uplinks. You would like to use your lower frequencies more for uplink. And then you don't want to spend your downlinks there. So then you can put your downlinks perhaps in the mid-band. And by that, you should sort of get more possibilities to focus and improve your uplinks on the bands which provides the best coverage. I think this is a key feature that will be very important. We also have a lot of uplink signaling and things. This could be sort of optimized. That will give something. I'll come back to the integrated sensing. There's a lot of spectrum aggregation. It's one of the key features now, right? But it takes a little bit of time to aggregate carriers. So if you can do that faster, you can more directly ramp up from sort of connection to high speed quicker. So and the time critical communication can also be further improved. So the sensing then, here it's one good ideas, right, that is being brought back then, and it is now implemented on 5G. I think it's important we will learn. This is a very new use case, right? So there's a lot of learnings to be made here. And I think in our test beds, we can clearly see that detecting moving objects like a drone, that you can do on kilometers distance. It works exceptionally well. You can also follow cars, and also the moving things gives you the Doppler shift, and it's easier to detect, etc. I think this will evolve. I think we should start with one of these more sort of clear and a little bit more simple, but high-value use cases. So drone detection is clearly one of these, and it's highly needed, right? So that is most likely to be a first use case. And then we will gradually improve, and we will integrate it better when we get into the 6G time frame. I think on the transmission side, it's fairly straightforward to send the radar pulses out of the antenna arrays and everything we have. But also on the receiver side, it's a little bit different compared to a communication receiver. So that could need more sort of hardware in order to be even more efficient. So there are some extra investments here needed in order to get this functionality. The 6G will be available in this, and there's a lot of this will be proprietary, but it will be, of course, in the physical layer. It will be in the sort of within a site, but also across the network. And there are different places then, so you can have this. You can have models both in the UE and on the base station side. You can have them in the RAN, and it could also be more sort of on this RApps SMO layer that controls parameter settings, and perhaps you can have sort of slice management and these kind of things. So this is the classical example now. If you want to know more about this, you can go out in the Ericsson booth here and discuss the details. But it's really a good example where you can use more data, right? Traditionally, you just use the reference symbols, and then you use the reference symbols in order to calculate the channel, and then you can do sort of a compensate for that, of course. But you can look at all the data, of course, and if you can look at more data, the AI can do better, and you can get from the red curve here to the purple one, and then you can get closer to the optimal performance. It's even so that you have too much data, so you can take away reference symbols and still sort of make the same performance. And here we have a performance gain, and you also have a reduction of overhead. And this is just one example. Gains here 10-20%, but I think you can find 10 of these, and then it becomes significant, right? So this is a very important thing, that we are now getting AI nativeness all the way down in layer 1 and layer 2. But then we also have it, of course, on the slice management, handling all of that complexity, configuration settings, etc. Energy saving. So it will be sort of all over the network, and it will provide gains across the board. So finally here now, just to conclude, we are in the middle of standardization. Study item is running, and we have now a timeline here. We will continue working with standard for a couple of years. Then we will freeze the standard, and we'll get the first implementable specification. Then it takes a little bit while. You need the ASICs and everything in the chipsets for the devices, etc. And then we can see that we could have products on the market 2030 time frame. But of course, it will be a little bit pre-commercial before that. You can guess the standard, and you can do that, and it will be more and more trials, and we have one of these Olympics coming up, etc. Right? So it will sort of be a lot of demonstrations along the line here. And an example of this, it was asked here about the devices. We are trying to line up also the device ecosystem here, so we are doing things with Qualcomm. We are sort of guessing the standard and fast-tracking the standard in order to get time to market advantages with them. We are working with MediaTek in order to test and evaluate new possible features. And with Apple, we have done trials now on this multi-rat spectrum sharing in order to guarantee a smooth migration from 5G to 6G. So the intelligent fabric is really the exciting future, and this will transform the way we live and work and meet in the society. So thanks a lot.
We are right on time, so I guess we have a time for a couple of questions. So any questions? Anyone? Oh, we have a question. Yes, it's going to be hard getting up there, but we'll try. So if I throw it, that's not going to end up well. Can you just please pass it on?
All right. Okay. Thanks, Magnus, for the nice keynote. So I'm particularly interested in physical AI. It seems this is a new kids on the block, which is now being talked in many conferences and so on. So how will the network work in this case? I mean, this is not a normal digital AI. I mean, could you just double-click on what kind of technology you're talking about, what kind of tokens? I don't think we can just plug and play current LLMs and expect them to deliver physical AI today. Thanks.
Yeah, that's a good question. I think there will be requirements on on transmitting the sequence of tokens, right? And it's time to the last token that will be important and so on. So the performance measures will be a little bit different. Then there is sort of the compute involved. Of course, in the beginning, you perhaps you can do the edge and a little bit more central, so perhaps that could work for some initial use cases. So then you need to move data back and forth in a way. But I think in principle, it's still sort of the tokens is represented by some bits, right? And you can move these packets back and forth. So I think it puts requirements on the sort of the bounded latency and everything, right? But in principle, I think you can move these things. Then, if you want to be more distributed, I think it's interesting to think about the memory, the state that is needed, because I think these physical AI applications will contain a lot of state, and that you need to store somewhere, and that's not easily moved, and so on. And if you have a smart city, it's a lot of state in that. So I think we really need to think about the architecture. So I like your questions, but I don't fully see exactly how this will be done.
We have another question.
Thomas Horacio from the French Ministry of Economy. Thank you very much for your presentation. And I have a question that is a bit related, I think, to the precedent one. It's regarding the geographic distribution of workloads, because I can't help thinking that there is lots of workloads being distributed a bit everywhere, from the device to the RAN, antenna RAN, to the core, and also to the edge sites. And I can't help wondering from a third-party developer developing services, why would I need all these different computing capacities everywhere in this whole continuum? So I think the question, especially because the connectivity is really good, so actually the data goes very, very fast between where it's produced and where it can be calculated. So I can't help thinking, do you think that this model is complementary, or will it be more different types of calculation models being in competition? So for example, more of a AI on device, and then actually you don't really need that much the other layers, you just need to have the core network that calculates a lot, or else no AI, not that much AI on device, but then we put everything on the thing, or will it be more competition, complementary? I can't help thinking this.
Yeah, I don't think we'll use all these alternatives for all applications. So if you think about the smart glasses, there you are very sort of limited on your compute, so then it would be attractive just to offload from the glasses to the edge in order to get help with the compute. So that could be one type of thing that drives that sort of use of that kind of compute. If you are more on this self-driving taxis, they have a lot of compute on board, so they will act differently. And if you think about it, if you are starting to have a lot of these taxis, and you have also the private cars, and gradually you will get so many self-driving cars, so it will be a value to be able to coordinate in between the cars, and it will be a value to see around the corners or coordinate all the cars in a crossing, etc. Then you need some central. So that will drive another type of use case, I think. And there perhaps you can use a larger data center for that city in a way. So I think it will evolve depending on the use case. But I think it's an exciting development in front of us. We don't know yet.
Any other questions from the audience? If not, yeah, you can have another one if you want. Yeah, okay. Thank you.
Yeah, thank you. I hate to stand between the lunch and here. So thanks, Magnus, for the wonderful questions. So my question actually is, I understand your intelligent fabric. So in the intelligent fabric, can you provide some kind of hooks to help the operators to provide some kind of new monetization model. Yes, I love money, right? Money is good. But I tip my cap to you and your colleagues that provided a very good intelligence, resilience, and the efficiency to the network. But now I want to be rich in 6G, right? And then so can you help me with that? Like, okay, in your intelligent fabric, can you come up with some kind of hooks? Because I understand we ask about token, but I have a doubt that token may not be the right way to go that route. So I'd like to check on you. Thank you.
Yeah, I think it's not really a technical question. I think there has been a lot of different possibilities to monetize 5G, right? But it has been a competition between operators, and it's been very difficult to charge for something, and then your competitor says it's for free, right? And you have this built in that if you have invested in it, you get a little bit of overcapacity, so it's sort of a short-term thing just to attract more customers by giving something away. And by the way, you get this sort of spiral to the bottom, right? And that's where we are now, and there are operators trying to break this and try to charge for some premium, etc., right? So I think you need to look at it like that, and now there is a clear need for this compute. I think that's a big investment, and you shouldn't give that away, basically. So from a business side, you should charge for that compute, of course. There is a huge need for this uplink. You need to densify networks, you need investments. I think if you do these investments and you get sort of a superior network, you should charge for that. And I don't think competitors will be able to say uplink is for free for us, because that requires investments, right? And if you can get into that spiral instead, you invest, you get a return. The competition try to also to invest in order to get return on their investments, and you can gradually build that up. So everybody can make more money, I think, and provide more high-quality networks for all of this future we see, right? So we need to turn that around, and I think it's mostly business relationship, business decisions, and connected to something which is sort of sustainable over time. If you invest in it, the others can't give it away. Something like that must be. Thank you.
Small token of appreciation for your keynote.
Yeah,
Thank you very much.